Hello students, in this video we are going to solve one numerical example on work energy principle. So let us read the statement. Determine the work done by all the forces acting on the block of 18 kg as shown in figure as it moves 12 meters upwards along the plane. The coefficient of kinetic friction is 0.2. So take coefficient of kinetic friction as 0.2. So here you have to find out the work done by all the forces acting on the block. So to know what are the forces acting on the block, so first let us draw free body diagram. So FBD of block. Tell me now, what are the forces acting on the block? Its own weight of the block, that is nothing but gravitational force, say mg. The block is moving on the inclined plane, so the plane will offer a normal reaction on the block, say nr. Applied force 60 newtons, which is acting at 30 degrees with respect to the plane. So it is 60 Newton acting at 30 degrees with respect to the inclined plane. As the block is moving up the plane, the friction force will act down the plane. See, the coefficient of friction is given. So the friction force, it will act down the plane. And what is the magnitude of friction force? It is coefficient of friction into normal reaction. So it is coefficient of kinetic friction, right? So these four forces are acting on the block. So for our convenience, let us consider this as x-axis and y-axis. Means now the block is moving along the x-axis, that is along the plane. Now resolving this weight into two perpendicular components, that is along the plane and perpendicular to the plane. So here this angle is given 35 degrees. So the component adjacent to the angle is cos. So it is mg cos 35. Other perpendicular component mg sin 35. Similarly, resolving this applied force of 60 newtons into two components along and perpendicular to the plane. So along the plane 60 cos 30 and the other component is 60 sin 30. Right. Now you have to find out the work done by all these forces. So first, work done by applied force. So work done by applied force is given as force into displacement in the direction of force. Now the block is moving along the plane by 12 meters. As it moves 12 meters along the plane, so you have to find out the work done. So you have to see the component of force acting along the plane, because the displacement is along the plane. So the work done by the component of force along the plane is 60 cos 30 into displacement. You can say that F cos theta into S. So here it is 60 cos 30 into the displacement is 12, right? Next, the work done by, say, friction force. Work done by friction. Work done by friction force is always negative. Minus magnitude of friction force is mu k into normal reaction into the displacement, right? And the friction force always acts in the opposite direction of motion, opposite direction of displacement. It is always negative. Now to determine the normal reaction, let us use the equilibrium equation in y direction. That is summation Fy is equal to 0. Because the block is moving along the plane, so there is no displacement in normal direction, that is along y axis. So the block is in equilibrium in y direction. So I am writing summation Fy is equal to 0. So it is plus nr minus mg cos 35 plus 60 sin 30 is equal to 0. So this gives you normal reaction is equal to mg, mass is given 18 kg into 9.81 cos 35, yes, minus 60 sin 30, that will be 30. So the normal reaction is given as 114.64 Newton. So it is the normal reaction offered by the plane on the block. Now the magnitude of friction force is equal to minus coefficient of friction is 0.2 into normal reaction is 114.64 into the displacement is 12 meters. Right? It is moving along the plane by 12 meters. Next, the third force is work done by gravitational force. See, here the block is moving along the plane by 12 meters. So what is the vertical displacement of the block? Say h. It is moving up the plane. So vertical displacement is upwards. And the plane is making an angle 35 degrees. So from this right angle triangle, vertical displacement h is equal to 12 sin 35. But the gravitational force, weight of the block is acting downwards. Here the displacement is upwards. So the work done by gravitational force is negative minus mgh minus 18 into 9.81 into h is 12 sin 35. So that gives you work done by gravitational force. Now the fourth force is work done by normal reaction. We know that the work done by normal reaction is always 0 because there is no displacement in normal direction. So the work done by normal reaction is 0. Now do the calculations and tell me what are these values. So work done by friction, it is minus 275.14 joules. Work done by the applied force, 623.54 joules. And work done by the gravitational force is minus 1215.38 joules. So these are our final answers. Understood? So the work done by the internal forces like tension and the work done by the normal force or normal reaction always 0, being there is no displacement in the normal direction. Thank you.